anything and everything moves on the earth, right? I'll talk about this in a very detailed manner in oceanography. Now, once let me quickly give you a recap what we have learned from the day one. See here, we started with the origin and evolution of the earth, right? We learned about Big Bang theory, right? Then later on, what did we study? We studied about the origin of the earth, the atmosphere origin of the earth, and then we went into the layers of the atmosphere, right? In fact, we started to study about this earth, its origin, and the evolution of the atmosphere, right? And we have also studied about the positions of the sun, right? Apparent movement of the sun. That means this sun, this earth, how is it moving around the sun and the seasons, right? Later on, from here, we moved into the layers of the atmosphere, and in each layer, what is the phenomena that is taking place that I have explained you. Little later, then we went on to understand the circulations, primary, secondary, and tertiary. 3 types of wind systems are there. I have explained you that wind system. Now, in a nutshell, this is what is climatology. There are a couple of other topics in climatology that are left. One, classification of climate. That is Köppen's classification of climate. Now, Köppen's classification of climate, what I feel is that you will be able to understand when you know about the oceanography and geomorphology also. I classify that as advanced geography. And here we have also learned about what are jet streams, how the winds move in a detailed manner. Now, today, I'll put a temporary pause to climatology and then I'll go for the geomorphology, explain you the basic concepts. Right? So, climatology, geomorphology, and oceanography, when you have the basics, you can understand environment, and then once you understand the environment, we have to come back to geography and understand the human geography. This is how you need to study, right? So today, my agenda is to explain the geomorphology. We are going to enter into geomorphology. Climatology, basics we have dealt, and in advanced concepts, I'll be explaining you in further classes. Now, within the geomorphology, the first topic that we have learned in the previous classes is Big Bang theory. How did the Earth origin took place? How did the universe origin took place? But today, I have to explain you what is there within the interior of the Earth. Okay? That is, within the geomorphology, it is the topic that I am going to teach you is interior of the Earth. I think my voice is clear now. Harsh, vote ke liye gaya tha, ghar gaya tha. Harsh is saying that he went to vote. Kisko jita rahe ho? Exit polls are out. Yes. It is estimated that it's not the NDA alliance is going to form the government, but we do not know. It is always prediction. Exit polls can go wrong as well. Only tomorrow we'll get to know in the evening. Chalo, it's a very good franchise that you have exercised. Now quickly come back. We are going to learn about the interior of the Earth. And in the interior of the Earth, firstly, let me tell you, how are we going to learn and what are the concepts that you need to know. See, interior of the Earth means today the place where we are standing on the Earth. This is the surface of the Earth. Okay? This is the surface of the Earth, the place where you stand. Now, what are we going to try to understand is, we go deep into the interior, into various layers of the Earth, and try to understand what do we have in the interior of the Earth. Now, this is what is the agenda of today's class. Now, to understand this, first thing, what are the sources we have? What are the indirect sources we have that we need to know? Right? So, the deepest mine that we have ever dug till date is maximum of 14 kilometers we have dug into the interior of the Earth. Right? Now, what is the radius of the Earth? Around 6,600 kilometers. Okay? What is the diameter of the Earth? Around 13,000, near to 13,000 kilometers. See, if you started to measure directly from this point to this point of the Earth, the distance is near about 13,000 kilometers. Near about, I am talking about. Okay? If such is the largest distance and the deepest mine that we have ever dug is hardly 12 to 14 kilometers. Now this is the deepest mine that we have ever dug. How did we get to know what do you have within the interior of the earth, which is present at 6,000 kilometers into the interior of the earth? You know that in the childhood you might have learned about what is core, what is crust, what is mantle. At least these things you might have listened, right? You have heard about it. Now, how did you get to know that within the interior of the earth you have these various layers? There is core, outer core, crust, mantle, surface. How did we get to know? By studying volcanoes. ठीक है. So, to study the interior of the earth, firstly, you need to know about the sources. Now, these sources are broadly be classified into direct sources and indirect sources. Right? Direct sources and indirect sources. Shaurya says, sir, by studying the volcanoes. Yes, absolutely. See, volcano is one of the medium in which the material comes from deep in the interior of the earth. So volcano is sending some kind of hot material. That means the interior of the earth should have been hot. Right? One source is volcanoes. Volcanoes are considered to be the materials of direct source. Now, what are the other sources? Yes? Mining. But some or the other way, with the help of this mining, we are able to know what do we have in the interior of the earth. Plus, what are the sources? Deep ocean mining. See, if you start to dig on the surface, you can go to 12 kilometers. But Naveen wants to go on to the bottom of the ocean and drill the ocean, because he'll get a material of different kind. So when you start to study that material, that is also one of the way. I can say this as next. Geological time scale, but how? Yes. In the beginning of the Big Bang Theory, I told that when you start to study about the celestial bodies which are there in the space, we wanted to study Mars, we wanted to study the various celestial bodies which are there. Now these celestial bodies, they might have also developed core, mantle, crust, but they are exposed. Now today you wanted to go and study that rock. Maybe that characteristics are aligned with the characteristics that are there on the earth as well. But which are the planets that you have explored? मुश्किल से मार्स पे पहुंचा अपन, right? And did we get the material from the Mars? There are some other materials called asteroids, shooting stars, right? Shooting stars are there, asteroids are there. They are sending certain kinds of rocks onto the earth. If you study them, maybe that part might have been the core of another planet. That part might have been the core crust of another planet. We can understand the rocks, right? So indirect sources are studying celestial bodies. Next, can I call this as studying celestial bodies as nothing but studying meteors, right? Then let's see online. So earthquake waves, seismic waves, meteors. Yes. Earthquakes, yes. See, the biggest source that we ever have till date, man did not go into the deep into the interior of the earth, but earthquakes have been. By studying the earthquakes, we can actually study the interior of the earth. Earthquakes or So till date, if you look into, man has studied these earthquake waves or earthquakes. Earthquake, whenever it is released, there are certain kinds of waves that will be released called as seismic waves. Now these seismic waves are of different types, right? S wave, P wave, multiple waves are there. I'll explain in very detail there. Now if you are going to study that waves will help you to get to know what do you have within the interior. Now other ways in which you can study is magnetic field lines. How and all, I'll be telling you. See, firstly, volcanoes are direct material because we directly get a rock to study. Mining, again you get a direct rock from the interior, and the deepest mine that we have ever dig is in the Kola Peninsula. Now where is Kola Peninsula? Russia. Okay? This part of the region. This is what is Kola Peninsula. Here we have dug deep, right? So these are the sources in which you'll get to know about the interior of the earth, right? Now here, for your examination, you have to study in very detail about this particular seismic activities, right? So you need to know about this. So how did man has studied about the earthquake, and about these earthquakes we are able to identify the interior of the earth, right? Okay, so let's quickly start with the concept of seismic waves. Got it? Now, firstly, how many of you have experienced an earthquake? Everyone? So how did you get to know that it is an earthquake? Earth was shaking. Now why is that earth shaking? Because of the movement of the plates. So what did you study in your graduation? Law. Okay. Now because of the movement of the plates. Tectonic plates. Of course. If I started to shake this particular body very vigorously, this will shake. See, firstly, what is an earthquake? Earthquake is the vigorous shaking of the earth, maybe some part of the earth. Now, whenever that shaking happens, it is because there are certain kinds of waves that are being sent. Is earthquake the release of energy, or earthquake is nothing but the release of energy? Earthquake always happens because there is some kind of energy that is released, and that energy is coming and it is being passed through that part of the earth, right? Now here, the energy is always transferred through the form of waves. Today I am standing here, I am speaking. How are you guys able to hear? Because there is a sound wave that is traveling all the way from my voice box, and then it is vibrating the eardrum which is you have with the same frequency, right? That is why you are able to hear, right? Likewise, earthquake is also a wave. Now what is a wave? That you need to know first. What is a wave? Shaurya says mathematical function होता है, sinusoidal. आसान भाषा में बताओ. Movement of energy. Very well said. See, wave is always, it is the transfer of energy. Suppose this is point A, this is point B. Wave means it is the energy from point A is being transferred to point B. Okay? Now here, whenever this energy is transferred, some particles can be there in this part of the region. Now these particles can move in this direction, can also move in this direction, can also move in this direction. Now just imagine, to make it little more simple, let's take a particular brick. Okay? What I'll do is, first I'm trying to explain you the concept of wave and the concept of functionalities of the wave. Only then you will be able to understand these waves in little more detail, because seismic waves are nothing but they are waves. Now imagine this is a brick and there are some particles within the brick, right? Brick is a solid, so all these particles are very closely packed and tightly packed, right? So I have decided that I am going to send some waves through them, right? So this is point A and this is point B. I am going to send some waves. Maybe I've stood at point A and I wanted to shout very quickly, so very loudly. When I am shouting loudly, the particles might vibrate here, right? You bring a very big sound box. Don't you think these particles will vibrate? They'll keep on moving, right? So that is called as propagation. Okay? If the particles are moving, they are called as the propagation of the particles, right? So imagine I am sending a wave from point A to point B. What is the direction of the wave? From point A to point B. Now, how does the particles move is called as propagation. Suppose if I pick up a particle as this, and this particle is also moving in this direction, right? This is direction A1. If I say that this particle is also propagating in this direction, see here, if the wave is moving in this direction and the particle is moving in north-south direction, what is the angle it is making? Perpendicular, 90 degrees. So the direction of the wave is from A to B, but the particle propagation is perpendicular. To make it little more simpler, can I draw a line like this? This is the direction in which the particle is moving. Next, see here, wave direction is in this way and particle movement, it is in this way. In simple format, I can say that this is the particle motion and this is the wave motion, right? So this is called the particle motion and the wave motion perpendicularity. Now see, sometimes there can be a possibility that your waves can be moving like this. The wave might be moving from A to B and your particles can move in this direction. Just a minute. Imagine this is a particle. It is moving in this direction. So is it the propagation of these particles, is it parallel to the wave or perpendicular to the wave? Parallel to the wave, right? So in the second case, you will see that particles are moving in this direction and the propagation of the, here this is not particles, it is wave. Wave is moving from A to B, but propagation is also from A to B. Now what is this? Are they parallel to each other or perpendicular to each other? Parallel. See, any wave which is moving in the atmosphere, wind, if it is generating energy, that wind will also be moving either parallel or perpendicular propagation itself. If I am speaking, that means there is a wave that has moved and it is maybe some dust particles in the atmosphere, they might be moving in this direction or they might be moving in this direction. Now everything in the world is always transferred. The energy is transferred in the form of wave from one place to another place, and that energy, if it is strong enough, it can destroy you, and if it is not strong enough, it can sometimes help you. Now earthquake, whenever it is generated, earthquake is the waves of the earthquake which is there, they shall be traveling from one place to another place across the earth. Okay? Imagine that there is an earthquake that is generated here at point A, right? Now this earthquake will start to send the waves across the earth. Means, look here, these are the directions in which the waves can travel. In other words, let's see that there's an earthquake in Afghanistan at this point, right? Now this earthquake will start to send the waves in every direction. But a person who is standing on the other side of the earth and a person who is standing here, who will experience more damage? Someone who is standing near. Why? Because the energy strength of the wave is more. And this person may not experience that high. Right? So here some basics that you need to know. Whenever an earthquake is generated, the earthquake is generated from a point called epicenter. Is the place where the energy is first reached onto the surface of the earth. Focus. Look here. Look here. You know about plates. Now, I imagine that you do not know about the plates. I'll give the knowledge about the plates little later. But here you need to know the concept of focus and the epicenter. See, epicenter is the place where the first contact of earthquake waves come and reach, and that is the place where the highest intensity or the highest energy is released at that point. Right? See, look here. The earthquake might have generated here. Right? This is called as focus, the place where the earthquake generation took place. That is called as focus. Now, what is called an epicenter? Epicenter is always above the focus. The nearest point on the surface is called as an epicenter. Right? The fundamental difference between epicenter and focus is that epicenter is nothing but the place where the energy reached onto the surface first. Right? The place where energy reached onto the surface first. Now, what is focus? Focus is the place where an earthquake generation has started. Now, this is also called as focus. Sometimes it is also called as hypocenter. And this is your epicenter. Okay? It is also called as hypocenter or epicenter. Yes. Shaurya says that, sir, if I am throwing a stone into the water body, there is ripples that takes place. That ripple is nothing but transfer of energy. Right? Now, highest damage kahan par hoga hamesha? It is at this place. Because from the focus, this is the nearest place. It is 99% of the time, it is always right above the focus itself. But look at this earthquake waves. They are also able to reach here. They are also able to reach here. They are also able to reach here. Now, to make it little more simpler, imagine that this is your earth. Right? If an earthquake is generated on one part of the earth, the waves are traveled across the earth in all the directions. By using these waves, we are able to understand what do we have within the interior of the earth. Now, earthquake waves have been studied in very, very detail. Now, these waves are broadly be classified into Okay. Earthquake waves are broadly classified into body waves and surface waves. Now, what are these body waves and what are these surface waves? These are some things that you need to know. How many of you have read the NCERT? Climatology you have read. So, from now on, I want you to read the chapter number 2 of class 11. Right? This is where all this content is given. But that is written in a very briefly. Here you need to understand in little more detail. right? So broadly, whenever there's an earthquake, the earthquake will release two set of waves. One is body waves, another is surface waves. Now what is body waves? Body waves in literally means they travel within the interior of the earth. They travel within the body of the earth. Look here, if this is your earth, you need to have very clarity here. Surface waves means they travel on the surface, जहाँ पे हम लोग खड़े हैं. Now body means they are traveling within the interior of the earth. I hope what do you mean by interior? From the core, the center of the earth within the body. Now these body waves are broadly be classified into two types. Primary waves or P waves. Secondary waves or S waves. Right? So primary waves travel faster. They have some characteristics. They are similar like sound waves. There are certain characteristics that you need to know. See, similar kind of studies have also been done in the laboratories. How do we get to know that primary waves have these characteristics? Because we generated some earthquakes in the laboratories and we started to study. Whenever there is an earthquake that is generated, there are two set of waves that are traveling through the body of the earth. Now, one is called P wave, other is called as an S wave. P wave has certain characteristics and S wave has certain characteristics. Now, when we studied about these two waves, we got to know what is there within the interior of the earth by using the seismographs. Now, what is a seismograph? Seismograph is a device which will start to measure how much earthquake intensity has come up. What is the magnitude? In literality, it is magnitude. Right? Now, how is this measured? First, let me tell you how the measurement of the seismograph takes place. See, seismograph measurement is always done through a small machine. Look here. You will have a knob like this, which is made up of roll. Right? Now that will continuously be rolling. And you have an other machine of this sort. If there is an earthquake shaking, the pencil which is there, it will keep on shaking there. Now what is the intensity of shaking that took place? A graph is drawn like this. In your NCRTs and all, you have a graph drawn like this. If this is the box, this is the graph that is shown. Now what is that graph? That graph is nothing but whenever there is an earthquake, a small sketch that shall be drawn. Now this is what is shown in your NCRT. Right? How come these lines are drawn? Because of the vibration that has taken place. Right? Now using these lines, this is called a seismograph. If there are big lines, that means the earthquake might have been so dangerous, vigorous. If there are small lines, that means the magnitude of the earthquake is not too high. Right? So this is how the measurement of the earthquakes takes place. Right? So you also know about focus, you also know about the epicenter. Now I want you to tell you about some other interesting aspects, that the characteristics of these waves is that P waves, they can travel through solid, liquid, या gases. Number one. Next, if density increases, density of the material increases, then the speed of the material, the speed of the wave, in fact, instead of speed, I'll write velocity. It would be a right appropriate. Now, these are some characteristics that we got to know when we are studying the earthquakes in the laboratory. Right? So that means, if suppose this material, while it is passing through a less dense material such as wood, here the shaking will be less. But if this material is passing through a high dense material such as iron, the shaking will be more. Right? The velocity of the wave is also more. The higher the density, the more is the velocity. Higher the density, the more is the velocity. Now you tell me, out of solid, liquid and gases, which is more denser? Solid. Now whenever this wave is traveling through the solid, their velocity, that means the speed is very, very high. Yes? Now, fundamentally, this is what we got to learn. Likewise, your S waves, they can only pass through solid. Gas, they cannot. Liquid, they cannot. Right? Second thing. Same is this. If the density of the material is higher, their velocity is also higher. But this cannot pass through gases and liquids. For suppose, if I have a bowl of water, and I've decided that I'll be sending P wave from here and S wave from here. This P wave, see, it can travel, but here, while it is passing through the liquid, it might change its direction. Reflection and refraction you might have seen. But still, it will travel, and while it is moving, or else while it is changing its direction, again while it is going out from the water, its direction might get changed. Right? Bachpan mein padha hai na, light. Light is also a wave. How am I able to see you? Because in the atmosphere, you have certain kinds of waves which are having 400 to 700 nanometers ka light aa raha hai. Visible spectrometer, that is the spectrometer wavelength through which I am able to see you. Any light that has the wavelength, you and me can see. If that light is not having a similar kind of wavelength, then you cannot see me. If there are X-rays, they'll create a shadow of bones. Likewise, everything on the earth, the energy is always transferred through the waves. Now, this wave, it is moving slower here, it is moving maybe a little more slower in the air. Right? Instead of air, let's consider this as a solid. Okay? Yes, solid maan ke chalo. Right? Now, coming to the S wave. Look here. The same S wave, if I am passing through the solid, this S wave will go, but as soon as it touches water, it will die. Right? Now, these are the characteristics. These are the characteristics. Reasons, see, even scientists do not know. If someone can identify, they'll be in line for Nobel. Right? Okay. Apart from that, right. Now, one more thing. P waves are faster in traveling and S waves are slower in traveling. Right? Next, P wave has few more characteristics, such as they act like sound waves. Now, what are sound waves? Transverse waves. Okay, sound waves are mechanical waves. Transverse waves, जानते हो what are transverse waves? P waves are like sound waves. They are also called as transverse waves. Now, what is this transverse waves? See, in simple terms, I will not use the word transverse. It might lead little technicality. See, they are just like sound waves. How does sound wave travel? A medium is required. Sound always needs a medium, right? See, it is like this. if you look into the propagation and wave direction, they are parallel to each other. Right? You got to understand what do you mean by parallel. I've told that particle motion and the wave direction is in the same way. Next, if you look here, they are like transverse waves. Wave direction and propagation of particles, they are perpendicular to each other. Did you understand this point, fifth point? Online, any doubts? Please let me know, because this is very, very important point. This is the most important point. See, P waves always stretch and squeeze. Look here. P waves stretch and squeeze. Okay? S waves do not stretch and squeeze. They are transverse in nature. Exactly transverse. That means P waves only stretch and squeeze. That means here, look at these particles. P wave ka characteristics stretch and squeeze means, let's imagine this is a solid and here the particles are there like this. If the wave is going in this direction and from A to B, here P waves will only move in this direction. And what is the wave direction? Same direction. But S waves, they move in this direction. Now, which waves are dangerous? Why? It is in opposite direction. So why is it dangerous? Let's imagine that there is an earthquake that is generated here. Which waves are first generated? The first generated waves are primary waves. That is nothing but P waves. From here, P waves will start to move. Right? Then, पीछे कौन सा waves आएगा? Secondary waves. The S waves will start to follow them. Right? S waves travel slowly, but P waves travel faster. If imagine that we have a technology that we can identify P waves and tung alarm bajaya apan hai across the earth or across the region, don't you think we can save lives? Then why are we not able to do it? Basically, the difference between these two waves is hardly less than 2 seconds. Okay? Just not even 2 seconds, 2 seconds se bhi kam hota hai. They come up with very, very fast. In simple terms, just imagine the government of India and across the globe, they are trying to achieve this. See, P waves and S waves, they are sent from an earthquake. Imagine that there is a hypocenter or a focus. This is the place where the earth has broken and then the crust is broken, and from here, the waves will start out to come. Yellow color component which you are seeing, they are called as primary waves, and these waves are called as secondary waves. Now see here, as soon as these P waves comes and touch, this point is called as epicenter. Epicenter is always the nearest point to the focus on the surface of the earth. Now, this is the place where you will see the highest damage. Right? Now, seismographs are also placed here. Look here. I'll place a seismograph here also, here also, here also, here also. Like that, in multiple places across the earth. The graphs that I see, they might be having different magnitudes. Okay? You might have heard about what is the magnitude of the earthquake. See, magnitude is always measured at the epicenter. सबसे नजदीक जो सेस्मोग्राफ है ना, उसके ऊपर क्या ग्राफ आया, वो चेक किया जाएगा. And that graph has some scales. On that scale, you will tell that the earthquake magnitude, which is epicentered in Afghanistan, has this much magnitude, 6, 7, 8. Richter scale. Now, what is intensity of this earthquake? The intensity is always measured how much damage it created. Okay? This is measured on mercantile, that is MMR, mercantile mercantile scale. Okay? Marsali mercantile. I'll tell you about this little later. Magnitude is the one which is measured on the Richter scale. So, always such kind of measurements or seismographs, they are placed across the globe. Many are there, right? Now see, there was a project which was envisioned by the many meteorological departments and seismological departments that they wanted to do this. As soon as this earthquake comes, if there is an alarm system, and this alarm system, if it can intimate the nuclear power plants, nuclear के साथ जो कुछ भी हम deal करता है, now with that immediately they can shut off, right? Wouldn't it be very good, so that it can intimate across the globe and immediately the critical infrastructures which are there, they can shut themselves? It is. In fact, we are working on this project, but this project is not a reality. It is still dead. We are facing so much of time difference is less than sometimes 1 second, less than 2 seconds. But even that 1 second and 2 seconds sometimes save the life. How? Nuclear power plants are there. If the intensity, if the magnitude of the earthquake is more than 9.5, it is a very big earthquake. Maybe immediately within that 1 second you can shut off automatically. We automate every sections of the power plant, so that they can shut themselves. Now these are, in theory, this can be done, but in reality we are not able to do it, right? So till date there is not even a single project that was successful. Now see here, look on this graph, you will always see the P waves come first, followed by S waves, then followed by surface waves. See the same set of waves which they have come onto the surface. Imagine, look here, while they are traveling through the body, we call them as body waves. Once they come onto the surface, see, let me show you. Hypocenter of focus, the earthquake started. Till here you will call these waves as body waves. P wave ka characteristic kya? It can travel through solid, liquid and gas, moves faster, and if the density of the material increases, they can also increase their speed. That is velocity. Same is the characteristics of the S wave. S wave cannot travel through liquid. Now imagine that there might be a lake which shall be present here, or deep ocean which is there. Can this S waves travel through them? No. That means if I am placing a seismograph here, will my seismograph record S waves? No. So this is how we got to learn about that. If the P waves which are there, if these P waves, they can come and reach here, they show themselves. But on this seismograph, there are P waves coming in, and these P waves are coming with very good speed, and followed by S waves also. That means we can say that from this point to this point, there is no water or there is no liquid. But I can say that here I have liquid. So in this manner, the study that we are going to deal with has immense research that has been done. Across the globe, scientists have come together. Their studies have been put into one single paper, and finally we got to learn about what do we have within the interior of the earth. Right? By studying just these characteristics. Now you are clear with the characteristics here. Right? So as soon as they are traveling, now once they have touched the surface, here a new set of waves will be generated. The characteristics of the waves will be changed. Here, a new set of waves that will be generating on the surface, you call them as surface waves. Surface waves थोड़ी देर के बाद पढ़ेंगे. Surface waves are dangerous. Surface waves are the one which creates damage. Now, first we need to study about the characteristics of P waves in little more detail and S waves in little more detail. I told you that P waves can travel only through solid, liquid gases, but S waves cannot travel through liquid. And characteristics of the P waves are, they are parallel to the direction in which the wave moves, the propagation of the particles and the wave direction is parallel to each other, right? Whereas S waves, the particles are, in fact, if the wave is moving in this direction, the particles will move in perpendicular direction. To make it little more simpler for you, what I'll do is, I'll pass this P waves and S waves through a earth, which on the earth where a house is constructed. Let's imagine this is your earth. You will understand why do you have the P waves more dangerous, S waves considered to be more dangerous as compared to P waves. Now, first suppose, imagine that you have a house here. Clear? First, I'll start maybe somewhere 20 kilometers into the surface of into the interior of the earth, below the surface, there was an earthquake, and imagine this is the point of an earthquake. Which waves are sent first? P waves. I am going to send P waves like this. Right? This is how P waves are also sent here. P waves are also sent like this. So they are sent in every direction. Right? कोई doubt है? Right? But to make it little more simpler, I'll only send one P wave so that we can understand things easier. Now, what is the direction? I call this as point A. The direction of the wave is from point A to B. How the particles move? Parallel. That means, can I say, your house which is there, the particles in the house should move like this? Right? Will there be a damage? There can be damage. ऐसा नहीं है, P waves will not create damage. It will create damage, but imagine that your house also has pillars. ठीक है? This is pillar 1, pillar 2, pillar 3. Right. So your house is actually moving in this direction. But let's try to understand the S waves. See, now I'll pass S waves, try to understand these S waves. From here, S waves will also travel same, and this is how the S waves moved after a couple of seconds. Now, what is the direction of the movement of the particles? Perpendicular. Now, how will the house move up and down or sideways? तो आपका pillars देखो, डैमेज किसमें ज्यादा होगा? First case or S case? It is in S case. So that's why S waves are considered to be more dangerous. But कुछ ऐसे waves होता है जिनका characteristics are they move round. ठीक है? That means the particle movement or the particles propagation can be perpendicular also. There are certain waves which can move like this. एक minute. If this is the particle, it can move perpendicular and then like this, circular motion. It can move perpendicular and it can also move horizontally. There are certain kinds of waves. Now they are called as surface waves. Surface waves movement propagation or the propagation of the particles is in a irregular manner. Now that irregularity will lead to large scale damage. Now to make you little more easier, what I'll do is I'll show you how the propagation of the particles takes place. Now please look into this particular diagram. It will help you to understand easily. So the waves that are being generated are of different set of waves. Okay, just a minute. First, look at this. Look at this movement of the waves and the scaling. This is literally how it is scaled. I have taken it from the IRIS website, जहाँ पे live plot किया जाता है, right? So when waves are moved, look at the movement. In the first case, how easily the waves move and the earth, the house which is there, it is not damaged in the first case. These are P waves. First, the house moves up and down and then it shakes. So whenever P waves are coming, firstly, the foundation of your house which is there, it gets little weakened. As soon as the S waves comes and hit you, The foundation is already little weakened. The old buildings which are there, they are already in a dilapidated state. They start to shake and they demolish. Right? So, likewise, if I have a bowl of, I have shown you this as an earth. Okay? Now look at this earth. This is our earth. अर्थ ना हमेशा दूर से देखो अच्छा लगता है, बट इफ दिस अर्थ, इमेजिन आई एम गोइंग टू ड्रॉ ओनली द लैंड, ठीक है, दैट मीन्स देयर इज अ बिग डिप्रेशन विच इज देयर. सो कैन आई ड्रॉ द अर्थ लाइक दिस? This is our normal earth which we draw, but I'll draw the earth where you have depressions and water within the earth. It is like this. This is your Pacific Ocean. Maybe this is your Antarctic Ocean. Maybe this is your Atlantic Ocean. I know it is very hard to imagine, but this is how our earth is. Right? If suppose there is an earthquake which is generated here. Right? Focus. This is what is your focus. From the focus, the earthquake waves will move in every direction. Now the nearest point you will call it as epicenter. Now this epicenter is beneath the ocean. सबसे ज्यादा एनर्जी कहां पे रिलीज हुआ? Epicenter, under the ocean. P waves can travel. That P waves will start to disrupt, and then comes the S waves. S waves will only come till here and then they die off. But when they come till the surface here, they still damage. Same is the concept. First they weaken the foundation and then they disrupt the foundation. So here the earth starts to shake. Imagine now this earth, the highest shaking is taking place here. Will the water be silent? No. Water will start to move up and down, and this will lead to tsunami. Now what is the minimum magnitude that is required for a tsunami to come or tsunami to take place? With what magnitude the earth should shake? See, magnitude is always measured like this. For example, magnitude of 1 means very minimal shaking has been there. Magnitude of 2 means exactly double the shaking of 1. Magnitude of 3 means double 1 का नहीं, 2 का double. ठीक है? 4 means 3 का double. That means for every 1 magnitude that you are rising, it should be double the shaking, the magnitude which is there, double the shaking should take place. Right? So it at least needs a magnitude of 7.4 magnitude. Now only at this particular vigorous shaking of the earth will lead to tsunami. Right? And it is not always true that whenever there is an earthquake beneath the surface of the earth, you will have a tsunami. Every day, I am telling every day, at least 1,000 earthquakes you will record under the surface of the earth. 1,000 earthquakes. You will be surprised to know that the interior of the earth, in the day 1, did I not show you how our earth looks, especially the India? Just a minute. In the day 1, I have shown you what do you see within the interior of the earth. India ka. See, there are lakhs of volcanoes which are there in the interior of the earth. What are the volcanoes which you see on the surface of the earth? They are just minimal in number. But within the interior of the earth, you have lakhs and lakhs of volcanoes. Now these volcanoes, they erupt every day. And whenever volcano erupts, sometimes earthquakes takes place. So earthquakes is a natural phenomena. Only those earthquakes where the humans live, that is a dangerous phenomena. See, no matter what, Himalayas, you will at least see earthquakes every now and then. The highest number of earthquakes are always taking place at Afghanistan. Now, why? Plate tectonics, I'll explain that, will be there day after tomorrow in the plate tectonics. By then, things will be easier for you. But let me try to give you an overview here. I wanted to show you practically how our interior of the earth looks like. See here, the surface of the earth, especially under the Indian Ocean, this is how it is. And what is this line? These are no doubt mountains. There are also volcanoes. Okay? They are called as ridges. Middle oceanic. They are in the ocean. They are called ridges. Ridges are nothing but mountains type, but they are full of volcanoes. Now these are the places you will see earthquakes as well. I'll show you the Indian Ocean. What are these? Literally volcanoes and middle oceanic ridges. How they are formed, I'll explain in the further class. This is just an introduction to it. But look here, these are the places where volcanic mountains are there. And earthquakes are bound to happen. Earthquakes are the phenomena of the earth where stabilize themselves. It is only we are exposed to that earthquakes and we fear. It is the human constructions that have taken place are fearing the earthquake, but earthquakes are quite natural phenomena. Right? So, now let's come back and learn little more in detail about these earthquakes. So, see here. Now, how can a volcano cause an earthquake? This is what is asked by Shaurya. See, if you are reading newspapers, Iceland mein there's volcanoes that are erupting. How many of you are aware? Iceland mein since December or so, many volcanoes have erupted, and within 24 hours there were 1300 earthquakes that strike that part of the region. Now imagine, let's see in this classroom, we are sitting in this classroom, all of a sudden there is a small volcano that came out of this classroom. Okay? Now, a volcano, while it is coming out, will it come silently? Is it not puncturing the earth? When it is puncturing the earth, your earth cracks. Now that cracking is nothing but your earthquake. You understood? Volcanoes, it won't come silently. In the volcanoes chapter, you'll understand in more detail. All of a sudden, a small volcano which is coming, in fact, it has to break the earth. It has to puncture the earth. When it is puncturing, it will make some cracks. That cracks will lead to earthquakes. So a volcano, if it is coming out in a large area, in Iceland, what happened is that within just 24 hours time period, 1400 earthquakes recorded on the seismograph, but not of high intensity, but of lower intensity. So scientists already told that there is a volcano which is going to come out, please evacuate the entire city, and they have evacuated. Grindavik karke ek city hai, very famous city. It is near to the capital city of that, and the famous tourist destination where hot water springs, anyone who goes to Iceland, that is where they pose themselves. Now that is no longer there, it is gone. Okay? Why? Volcanoes. That is volcano related earthquakes. Sometimes the volcano bursts out. So similarly, you will have these earthquakes. Now coming back to the interior of the earth. Abhi tak humne kya padha? The characteristics of the P waves and S waves. But our concept is about interior of the earth. Now, to study this interior of the earth, we have studied about the earthquakes, and they helped in understanding what do we have within the interior of the earth. See, there are many scientists. What they did was, scientists and many meteorological departments and seismological departments, they came together. See, imagine there are a group of scientists who placed seismographs across the earth like this. These are seismographs. First, suppose if there is an earthquake which is generated 30 kilometers into the interior and it started to come out. That means the waves will travel on the surface also, the waves will travel in the interior. Now, epicenter, where will you see? This is the place where epicenter is. Now the shaking here is of vigorous. Now this seismograph will report that सबसे ज़्यादा shaking यहाँ पर हुआ, highest shaking यहाँ पे हुआ, and what is the magnitude you can measure from the chart. Now they'll say that this is the epicenter with a magnitude of this much. But from the interior of the earth, I'm talking about from the interior, within the body, the waves can move also. Now those waves which are moving, you will see, yellow color means these are P waves. Okay? These P waves, they are reported like this. Okay? But they are not reported on few places of the globe. Now scientists questioned why. Number one. That means even I am talking about P waves. P waves can pass through solid, liquid and gases. Scientists questioned why is that this earthquake did not report on the Richter scale of these seismographs. Likewise, followed by, you will also see S waves. Green color means S waves. S waves also started to report, followed by the other one. Now these S waves, it is very surprisingly, they are not reported on major parts of the globe. Okay? Then they got surprised. Arey yaar, why is that P waves have been reported here and no P waves, no S waves here? But in few areas P waves and S waves are there, but their speeds varied. That means, look here, the P wave and S wave both came with same speed. But here, same speed. When P wave came with much higher speed and S waves did not come with good speed. Likewise, P wave came with less speed and no S waves. Like that, these kind of permutations and combinations have been studied, and later they got to learn that. That means, when they studied in the laboratory, they got to know that S waves are there, they cannot pass through water. That means within the interior, there could have been some kind of liquid component. Not groundwater, it can be liquid. Liquid can be of magma. Mantle, flowing mantle can be there. But mantle is not liquid, outer core is liquid. Okay? So, then they have said that Earth might have multiple layers. Now what are these layers? These layers are broadly classified as one, you have a core, and this is inner core. Around the inner core, you have outer core, and scientists got to know that this outer core is made up of liquid, right? Beyond this, you have mantle, and above the mantle, you have crust. Right? Inner core is solid, outer core is liquid. How do we got to know? Let me tell you. Okay? Now let's try to understand. Across the earth, there are some seismographs that are placed. Now these seismographs, they reported some P waves. They did not report some areas of P waves and S waves. Multiple combinations are there. Now let's try to understand. So there was an earthquake. Imagine that is generated at a depth of 30-40 kilometers into the interior of the earth. Now from here, if these are P waves, the epicenter is right above. Okay? From here, the P waves were reported on these areas. Okay? Across the globe, the P waves are reported. But it is very evident that as soon as the P waves are being reported at this part of the place, the timing and speed calculations when you have done, you have understood that the velocity of these P waves is very, very high. Right? Likewise, we have studied volcanoes also. Okay? Over a period we are studying volcanoes also. We integrated the study of volcanism. There can be a volcano which can come from this depth. The material can come from this depth. There can be a volcano which is present here, but the material can come from this depth. So when we studied all of these volcanoes, we got to learn that the deeper the material, more heavy is the material, more dense is the material. The deeper we go into the interior of the earth, the density of the material also increased. How? One study which we have done is through drilling. That is 13 kilometers, 14 kilometers we have drilled, and we got to know that as you go into the interior, the material also became denser, and that's the reason why we are not able to drill. Likewise, the volcanoes which are coming from the deep interior of the earth were also having more heavier material, right? So this is one study we have done, and in the laboratory studies we have done, now here we are practically experiencing, we got to learn that as they go deep into the interior, their velocity is increasing. But see here, this is mantle. Now as soon as they got into the mantle, their directions changed. It is not that they are directly passing like this. Their directions changed, and these directions are, they are reflecting and refracting. So like this. Now look here, outer core is liquid. That means these waves, they also entered outer core and they are moving. Now as soon as they touched inner core, some waves reflected like this. That means the entire earth is being reporting, or the entire earth is reporting these seismographic recordings, but those which are placed between the seismographs placed here, they did not report. And they called this zone as what? Shadow zone of P waves. Okay. Now what is the shadow zone of P waves? This is the shadow zone of P waves, where P waves are not found. Okay? Likewise, let's see for S waves. S waves, red color I am using. Now these S waves are also followed. See here, there is liquid. As soon as this S wave comes and touches here, they die. That means the seismographs which are placed here, they received both P waves and S waves, right? But the seismographs which are placed here, did they receive S waves? No S waves. That means you tell me whose shadow zone is wider? S wave shadow zone is wider. But S wave shadow zone is way wider, and this is how they have concluded that, chalo, that means our earth is having some kind of liquid within the interior of the, somewhere deep in the interior, and we'll call it as an outer core. And they said that though this is liquid, the density of the material is way higher. Now when they are asked how you got to know, they said that the velocity of the P waves increased. Though this is liquid, it is a denser liquid. I know it is little hard to imagine. For example, yes, liquid है but denser liquid है, solid से भी more denser है. Honey जैसा मान के चलो, honey से भी best example is let's take mercury. Have you seen mercury? Thermometer में होता है. When it is fallen down, is it liquid or solid? Liquid. Mercury is room temperature is liquid. Now imagine you take a full bowl of mercury and you put a iron in it. Will the iron sink? Maybe you put an iron bottle in it. Will the iron sink? it will not sink. You know why? Mercury's density is heavier, it is 13.6. Iron density is somewhere around 7. The denser, though it is liquid in nature, but it is denser, more denser, right? For example, if I am passing that P wave through the iron, it will move slower as compared to the P wave which I am passing through the liquid denser material. So likewise, this less denser material means less velocity, more denser means more velocity. And this is how we got to learn that there are P waves and there are S waves and there are some shadow zones. Now, these shadow zones are studied in little more detail, and we got to learn that our Earth has multiple layers. That broadly, this Earth is classified into on the basis of mechanical classification and chemical classification. Mechanical classification means what kind of material do you find as you go into the interior. Is it liquid? Is it solid? Or is it semi-molten? Is it plastic? It is based on the physical properties. Likewise, based on the chemical properties also we have divided the Earth. Right? So, the chemical composition of the Earth and the physical composition of the Earth as we go into the interior, this is what we need to know. Now, are you clear with this? Now, let's try to understand this through a small diagram. Look here. Watch this. Earthquake generated. Okay? From here the wave started. P waves are moving faster and S waves are followed. P waves, it has lifted the Earth, and then look at the S waves. And meanwhile surface waves, they come and then they destroy. And this will lead to large scale destruction. That means every earthquake will send 3 set of waves. One, primary waves, secondary waves, and then you have surface waves. We have studied about P waves and S waves. With the help of P waves and S waves, we got to know what is there within the interior. But let's try to understand and study about these surface waves also. As soon as they come and touch the epicenter, these surface waves will also start to move on the surface. So once again watch this, and then we'll go further. There are some online doubts. Where's the AC remote? Handle. You can off also. Clear है यहाँ तक? Okay, surface moves, pattern and all, I'll tell you. And once, see, look here, I want you to watch on the seismograph. As soon as the wave is generated, what kind of waves are recorded, you just look here. Earthquake generated, and then these are red color are P waves followed by S waves, and the surface waves are as soon as it is touched on the surface waves are also traveling. Now P waves recorded, followed by as soon as the S waves are recorded, here you will see S waves coming in, and then comes the surface waves. Who is more dangerous? P, S and surface. As compared to P, S is more dangerous. As compared to S, surface waves are more dangerous. Now surface waves are of 2 different types. One is R wave and other is L wave. R wave means relay waves. L wave means love waves. Okay? So relay waves and love waves are the 2 different types of surface waves. So propagation, let's try to understand. See here. Let me play it again. Earthquake. Then you see the twists and turns that are taking place. It is because of various densities and various layers. So likewise, I'll show you another image. This is the shadow zone of एस वेव सबसे ज्यादा होता है 103 डिग्री से लेकर 103 डिग्री तक, एस वेव शैडो जोन, whereas P wave shadow zone is 103 to 142. Very slight varying can be there. ठीक है, very why it happens I'll tell in anomalies. Basically sometimes the core which is there, the core can move from one place to another place. Imagine this is core is there, this core can move in the inner core which is there, it can change its place. And one more thing I have to tell you here, earth is rotating, your inner core also rotates, and in fact the speed of the inner core is more than what is the earth having, right? Outer core liquid, that is also moving. This you will learn in the day after tomorrow's class. Please watch here. Yes, first P waves, they are passing through various layers. This is crust, or else the top layer, this is mantle, and this is core. Why are they making turns? Reflection and refraction. Very good. Okay. Now followed by S waves. Let's look into the S waves as well. See, the black color component which you see on the screen is P waves, and now followed by S waves. As soon as they touch the liquid, they are dead. Right? Now scientists got to know that, yes, we have liquid core, and this liquid is the one which is coming out as the volcanic lava. And it is not always the lava that is coming out, it comes from mantle, it comes from outer core. It can come from various areas also. It can come from 20-30 kilometers also. It can come from 800 kilometers also. It can come from 3000 kilometers also. That how and all I'll explain in the volcanoes class. Right? Are you clear with this? Now this is inner core, outer core, mantle, and then the crust. So this is also rotating. Earth is also rotating. Within the mantle also there are movement of convections. Now what are that convections? Let me first show it to you. Liquid नहीं, actually वो solid ही है, solid flow करता है. Now let's try to imagine little more visually. See, this is outer core. ठीक है, ये outer core है. Inner core में इसमें दिखाई नहीं दे रहा है. Outer core says some material is trying to come out. And this material, as and when it rises, what happens is that they get cooled. ठीक है? Once they cool, they come to the near to the surface and then they cool. I am only giving an introduction into this topic. I am not explaining anything. I'll explain in the further classes so that you'll have an holistic idea. Like that, every material that comes near to the surface, they get cooled and they sink again. As soon as they get cooled, they become heavier. If they are hot, they are lighter. ठीक है? So this is how some changes which are happening in the interior of the earth, they will also lead to the destruction of the crust, and that will lead to the volcanoes. In simple terms, this is a convectional cell. Whatever you have seen, the rising magma, that is nothing but convection. Right? So we are going to learn about all of these things in the further class, but now to understand this, you also need to know what layers do you have within the interior of the earth. So coming back to the concept of longitudinal waves and transverse waves. So see here, how does a longitudinal wave move? Longitudinal waves are nothing but P waves. P waves are longitudinal waves. Wave moves from A to B. If this is your A and this is your B, and I put a particle here, right? Longitudinal waves are nothing but sound waves. They are also nothing but your P waves. A to B, the wave moves, and imagine that this dot is a particle. How does the particle move? I'll be erasing it. It is parallelly. See here. Stretches and squeezes. So can I write it like this? Yes. Let's look into the transverse wave. In the transverse wave, look at the particle. If I am putting this particle, the particle moves upwards and downwards. That means your S waves are like transverse waves, proper transverse waves, right? That is the fundamental difference between P waves and S waves. So S waves, they are light waves. S waves are like light waves. Now they don't stretch and squeeze, they tear apart. Right? Now they are. Propagation is देखो, Shaurya's question is that light जो होता है, if I put my hand, is the light being able to pass through my hand? Why? It's not about opaque. Actually, light always tries to destroy you and your skin. ठीक है? It always disrupts some kind of changes. If the intensity of the light is more, for example, UV light you take. UV light is there. Why is it creating damage to your body? It might pass and then it actually vibrates. ठीक है? They are very small, such a small waves which are there. They actually vibrate your skin. Now this light cannot vibrate. Less vibration, it is not harming us. Right? Always light is an energy. That is how you need to see here. Are you clear with this? यहाँ तक? अब prelims में ना यहीं से आता है questions. You go and look into the previous year areas. This is where the questions are. Now, I also need to show you the L waves and R waves. See here. This is the damage which is caused by P waves. This kind of damage will be caused by secondary waves. P waves, S waves. S waves mein crust itself is getting damaged. You see, this is the crust and this is the surface. Here the crust itself is getting the sine kind of wave. L wave, look at the particles. All the blocks are being disrupted. R waves. Now, सबसे ज़्यादा dangerous कौन सा है? L waves, right? So, let's try to look into this animation. It will give you a more little insights. This is P waves. They just stretch and squeeze a particle. ठीक है? This is a particle. They stretch and they squeeze. Yes, I'll be operating with the mouse, so just have a look here. P waves always stretch and squeeze. Next, let's look into the S wave. S wave में particle देखो ऊपर नीचे हो रहा है. Instead of that particle, you imagine a house which is present there, right? S waves move up and down. Wave is moving from one place to another place, but the particle motion is perpendicular to the direction of the wave, right? This is S waves. Now look at R waves. R waves is a dangerous wave. The particle motion is circular in nature, semicircular in nature. Okay? Look at the particle motion which is there on the screen with the violet color direction. Just look into that black dot. You'll get to learn that the black dot is moving in a semicircular manner. Now imagine you put your house in that region and see how come the particle motion is going to take place. Right? This is R wave. They are going to make circles, semicircle manner. Next, we'll go for the L waves. ये सबसे dangerous waves है. ठीक है? Like a snake it moves. Now imagine that you have your house is being first hit by P wave, followed by S wave, then followed by surface wave of R waves and L waves. ठीक है? So, in fact, alone sound waves will not damage your house. घर में तो रोज ही ऊंची आवाज से इतना डैमेज नहीं होता, but on a consistent basis when you are playing that loud music, sometimes the walls that get weakened. ठीक है? But followed by if you have S wave, surface waves, and then R waves and L waves, definitely dilapidation will be there. So earthquake is a set of waves. Now this set of waves is something which we fear always, right? I hope now you got the fundamental difference between P waves, S waves, L waves. Now look at these L waves, very notorious waves. Particle motion, dekho, if your house is there, the particles will move in this manner. Love wave, it is basically on a fun note this name was given. In fact, the person who researched this, his name is Love. Okay? That's why they call it as love waves. Another name is R wave, that is relay waves. Okay? R waves are nothing but the relay waves. This is the person who have researched this. That's why relay names. Right? So, now, ठीक है, यहाँ पे भी वाटर बॉडी में ट्रैवल नहीं करेंगे लोग. Surface waves, they die in the water, but energy is travel through a different medium. Only P waves can move in that. See, energy is not traveling only at that part of the place. जहाँ पे शौर्या का क्वेश्चन ये है, he asked that, sir, when these waves are getting dead, especially the S wave, such large amount of energy is coming and it is going to die when it is going to hit the water. So the surface which is in contact with the water, that is where it is released. Now, surface phenomena. Right? Now this is what is about the interior of the earth and the earthquake waves. So questions can be seen on in these areas. So please try to draw this particular table. It will be easy for you. Done? Now, here you also need to know the types of earthquakes. How many types of earthquakes can be there and what could be the causes? See, broadly, the earthquakes can be seen because of the shaking of the earth. Now, this shaking of the earth can be because of tectonic activity. Tectonic means tectonic earthquake, volcanic earthquake, collapse earthquake. It can be reservoir earthquake or explosion earthquake as well. So broadly, earthquakes are classified into 5 different types. See, what is this explosion earthquake? It can be because of nuclear explosion or any bomb explosion that takes place. Then also there can be an earthquake. Now he says, sir, earthquakes can be of man-made in nature. While metro pillar digging and so minor tremors or minor earthquakes can be there. Okay? Reservoir earthquake. Now what do you mean by reservoir earthquake? The best example is Koyna Dam. In Karnataka, what happened was, without studying the geology of that part of the region, what they have done is, they started to construct a big reservoir there. Already there is a fault. Fault in the sense, the plate is not stable there. Plate kya hai, I'll explain you in the further classes. But now imagine that Earth is made up of number of plates. Okay? Now these plates, they can be stable or they can be unstable. So, if suppose, just imagine that this is your Earth. Maybe this part of the Earth is not stable. Stable means it is made into number of pieces. And for some reasons, if you look into, someone has created a dam here on the not stable part. When you are creating a dam, are you increasing the weight or decreasing the weight? You are increasing the weight. How are you increasing the weight of that region? See here. Earlier, this is a surface and your river is moving like this. Okay? This is the place where you are living. Okay? And the river is simply passing through. But now what you have done is, you have constructed a dam. What do you do in the dam? You actually store the water here. And you'll keep a small opening. Whenever you want, what will you do? You keep that opening and you release the water. Now such large amount of water is actually being stored here. For that, what you need to do is, first you need to go and check the geology of that region. So, to make it little more simpler, maybe this is the surface of the Earth, and this surface of the Earth is not so stable, and a small plate which is there, plate kya hai, I'll explain in the further class. Now the plate which is made here, the plate is not so stable, and you will see an earthquake that can be there. Now such a kind of earthquake you got to see on Bhima fault. Now where is Bhima fault? It is in Karnataka. Okay, there is a river by the name Bhima. If you go through the Krishna river has certain tributaries such as Doni, Bhima, Dindi, Halia. उनमें से एक ऐसा tributary है, that is Bhima. On a Bhima, which is also called Bhima fault, on these faulty lines they have built a dam called Koyna. And this Koyna dam, weight increase ho gaya, and all of a sudden it has created an earthquake. So they had to shut this dam. They are only storing little amount of water. I'll explain this in a very detailed manner in the further time period when I teach you what are plates. Till then, consider this as a fact. Right? So that means you know what is a reservoir earthquake, what is an explosion earthquake, then what is collapse earthquake? Yes, mining activity. Wonderful. It is nothing but see, there could be multiple types of mining, open cast mining and closed pit mining. In the open cast mining, you don't see large scale earthquakes, but closed cast mining, you go to NTPC, National Thermal Power Corporations and all, in the southern part of India, what do is they dig deep into the interior of the earth. Kilometers together they keep on digging. And sometimes rainfall, excess of water leaching into that blocks and all, you will see the fall of that region. That will lead to an earthquake. Now, volcanic earthquake, I already told you. Volcanic earthquake is nothing but, it is like this. Imagine this is your earth. Now, from within the surface, if there is volcano which is trying to rise up, this volcano, what does it do is, it actually ruptures the earth. Okay? It will start to push the earth like this. First it will bump the earth. Wherever you see a volcano, why is volcano always a conical in nature? Yes, if suppose this is your earth, imagine this is the surface. From beneath there is a pressure that is acting. Because of that pressure, the crust which is there, it gets bent. Because so much of temperature is bending the crust. So it gets bent like this. So that's why you always see the volcano has a cone. Right? The more the pressure, the more will be the stable cone. The lesser the pressure, sometimes the volcano can fissure up, and imagine my fingers which are there, they are getting fissured. That means my fingers open up. From here also the volcanic material can come out. Now this is called as fissure volcano. But conical volcanoes, the pressure is too high. So that is the reason why you see always cones over the volcanic material. So best example, Iceland. Yes? Yes, example that you gave is? Okay, tectonic. Tectonic is because of plates. Yes, kind of. Similar kind of. Now these are the types of earthquakes that you need to know. There are 5 different types of earthquakes. One, tectonic earthquake, which is caused because of the plates. Second one, volcanic earthquake. Best one is Iceland, or else Anak Krakatau, Mount Sicily. Even India has one of the active volcano in the Narkandam. Okay? Mount Fuji also. They are all the examples. But recent example is volcanic earthquakes, Iceland 2024 May. Within 24 hours, you got to see more than 1400 earthquakes. So, itna large number of earthquakes in a less time period, they always indicate that there is earth is getting fractured because of volcano. And literally, you now get to see the volcano is flowing into the cities in Iceland. Okay? There is Icelandic tourism also. You see, Hawaii, if you go, I think I've shown this earlier also. What are these people doing? Playing with volcano. This is called volcanic tourism. Some volcanoes are violent and some volcanoes are not. Why? हीट तो होगा, लेकिन आइसलैंड में उससे ज़्यादा ठंड होता है, तो गर्म कांपने के लिए जाता है. Yes? Today it is active and later it can be dormant, right? So in volcanoes topic, I'll talk about the various types of volcanoes. Look here, enjoying the good evening there. Iceland में कभी होगा तो 6 महीना धूप होगा, या 6 महीना it is winter, that is summer. The winter is coming of Game of Thrones is nothing but they don't know that for 6 months the sun is going to be there and the 6 months sun is not going to be there. ठीक है? Okay, we'll discuss this in the further classes. Now, see, geography is like this here. It is always about some topics that we are going to learn today. Tomorrow you'll get more clarity. Day after tomorrow you get more clarity. It is because the topics are interlinked. Right? Okay. Now with this, I presume that you got to know what is the interior of the earth, what are the layers. Now, earthquakes bhi jante ho aap. What we will do is, we'll classify the interior of the earth. Classification of the interior of the earth. So look at this classification. It has 2 different types. One, one is based on the mechanical composition of the interior of the earth, and other one is based on the chemical. Based on the chemical, composition of the interior of the earth, it means to say that what is the material that is made up of crust. Crust is made up of what material? Mantle is made up of what material? Core is made up of what material? So broadly, based on the chemical composition, the earth is divided into, the topmost layer is called as crust. Then you have upper mantle, lower mantle, inner core, and the fifth one is outer core. Shaurya asked, sir, the deeper you go, you have more denser material. Why? Did you not learn in the Big Bang theory that any rotating object, heavier materials will come to the center and lighter materials will go out? Bachpan mein dadi chakki, if you might have seen, the powder is always thrown outward and the solid materials are always inward. It is because the denser materials are always near, because the rotating earth or rotating sun, any object which is there, the heavier materials will be towards the center. So here, as you go into the interior, as you go deep into the interior of the earth, the density increases. ठीक है? That means सबसे highest density किसका है यहाँ पर? Core का. Inner core has higher density. Though this is liquid, inner core is liquid, it is more denser as compared to the mantle. Mantle is a solid component. Now see, crust is solid. Mantle, solid. This is also solid. This is liquid and this is solid. ठीक है? The only liquid material which is there in the interior of the earth is inner core. Now why? Why? Shaurya is saying, sir, high temperatures है तो metals पिघल जाते हैं. Now let me give you what is this composition made up of. It is said that this particular material is made up of Cl, that is silica plus aluminium. Dominantly, your crust is made up of silica plus aluminium. What is silica? What is silica? मिट्टी. मिट्टी को सिलिका कहते हैं अपन. Right? In geographical terms, the dust and solid which you see, that is called as silica. Right? Second thing, what is this mantle made up of? Sema. That is silica, magnesium. Right? Now what is the core made up of? See, interestingly, both the core, the outer core and inner core, both of these materials are made up of knife, which is called nickel plus ferrous. I call it as knife. Sema, Cl. ठीक है? Cl, this is Sema, and this is knife. What do you mean by knife? अब शौर्या का कहना है, सर, at this temperature, the material gets melted. Now, why is that outer core material did not melt, but the inner core material melted? Magnesium, देखो बेटा, magnesium is only present till upper mantle and lower mantle. Inner core is made up of knife, nickel and ferrous. Inner core is also made up of nickel and ferrous, and outer core is also made up of nickel and ferrous. Now my question is, why is this layer liquid? Why is this layer solid? I told you this is solid, this is liquid, this is solid, solid, solid. The only liquid layer in the interior of the earth is inner core. But outer core is more heated, it is. Yes, absolutely. It is density of materials. Whatever you have applied, the logic is also true. See, it is with respect to two components you need to study this. One, density of the material. At this temperature and at this depth, the weight experienced by the earth at this depth is more. And at this temperature, that is liquid. And also, this is solid because the purest materials which are there, they are present here. As compared to the purity of the inner core and outer core, the more purest materials are present in the outer core. Of course, both nickel and ferrous is present in the inner core and outer core, but the more pure materials of nickel and ferrous are present in the... Sorry, I've written it as... this is your outer core and this is your inner core. I'm sorry. Inner core is solid and outer core is liquid. My bad. Okay? Outer core is liquid. The more pure materials are present in the inner core and less pure materials are present in the outer core. So because of that, at this density and at this this temperature, the earth is made up of liquid. Okay? Now, who will be experiencing the highest weight of all these layers? The innermost layer, which is considered to be the inner core, which is made up of nickel and ferrous, and it experiences the highest weight. Now, this is based on the chemical composition. यहाँ पे देखो chemicals की बारे में बातें किया जा रहा है. ये silica plus aluminum है, ये सीमा है, right? So, look here to make it easier. One is solid, then you have, this is liquid, this is nickel plus ferrous, Sima, Sial, Sima and knife. We are looking from the chemical composition, but from the different angle when you look into the earth. Now, we looked into solid and liquid, but we go into the chemical composition. This is it. But when we go into the mechanical composition means कितने डेप्थ पे किस टाइप का मटेरियल पाया जाता है. Is it solid, is it liquid or semi-molten or plastic kind of material? We go and look into the mechanicality. And before I go any further, I wanted to ask you that if there's an earthquake that is generated, you know that P waves are the one which can pass through solid, liquid and gas. Okay? And an earthquake that is generated just 2 or 3 kilometers beneath the surface, and very strong earthquake. An aeroplane which is about to take off and it took off into the air. Now, people who are traveling in that aeroplane, will they experience the earthquake or not? Your good name? Navneet. Navneet says no. Why? I told you that P waves are traveling through what? Yes, that is the right answer. See, basically, the P wave still moves in the atmosphere. But gases, particles are easily moved. They move from one place to another place as they keep on moving from one place to another place. Even if this wave is moving, that will not cause much impact. Okay? As that earthquake is moving from solid to gas and then to a solid aeroplane, by then the gas would have reduced its intensity. Okay? That's the right explanation. The particles are freely moving, so the wave will not. And in fact, your earthquake waves are this mechanical waves. Okay? They are mechanical waves. Now, what do you mean by mechanical waves? They need a medium to move. They need a solid, liquid, or gases. They always need a medium to move from one place to another place. So, as soon as a rays which are there, they are moving into the atmosphere, the particles are loosely packed from here and there, so it will not have much impact. Right? Another reason is, Shaurya said that as soon as they come and touch the surface of the earth, then they turn into surface waves, and a small amount of energy then goes into the air. It will not cause much impact. Right? So they will not experience. Now come back to this. Now I have to tell you about the mechanical composition. See here. This is how the classification of the earth on the basis of mechanical composition. Shaurya asked a very good question here. He says, sir, how did we get to know that a rock which has come from the interior of the earth, did it come from outer core? Did it come from inner core? It is because of the temperatures. Okay. See, we know there are many volcanoes across the earth. Now, lakhs and lakhs of volcanoes. Some volcanoes have a material coming out from the outer core. The material that is coming out, it has more density and it might have more temperature. Right? But a material which is coming from the upper mantle, it is less denser. And this material, when we come onto the surface, when we compare both of them, we can see that this material has not having high temperatures and this material is having more temperatures. So that is how we estimate. In the volcanoes topic, I have to explain a topic called partial melting. Now, when you understand partial melting, you will understand rest of the topics. Now, what do you mean by partial melting is that, see, suppose if I say that as you are going into the interior of the earth, okay, the temperatures here are 100, here 500 degrees, here 1500 degrees Celsius, here 2500, and here 6000 degrees Celsius. Right? Now I'm only giving you an idea. I'm not explaining. I'll explain in very, very detail in the further classes because I have to give you an idea on each and every topic. Only then you will understand these topics. So, firstly, what is a rock? What is a rock? Collection of minerals. Very good. If I'm taking a particular rock, in that I can see a single mineral or I can see multiple minerals. Right? Suppose if this is a rock and this rock can be made up of multiple minerals. This can be mineral A, B, C, D, E, F, right? Multiple minerals can be there within a rock, or a rock can also be made up of a single mineral also. Now let's imagine this is a rock which is made up of multiple minerals. Now, mineral A can be aluminium. Mineral B can be copper. Will they melt at same temperature? No. Every mineral has a different melting temperature. Now let's say A can get melted at 600 degrees Celsius, but B can get melted at 1500 degrees Celsius. Likewise, G can get melted at 200 degrees Celsius. J can get melted at 2100 degrees. F can melt at 6000 degrees. Likewise, you just imagine that there are multiple materials, they can melt at different densities. Right? Now, if I have taken this rock and I am sending deep into the interior of the earth, I have put it into a volcano. Okay, let's talk in Shaurya's language that there is a volcano, and I have put that rock into that volcano. Now, till what depth this rock will sink? Till, that means this part of the rock, only this part of the rock will sink from here to here. But what about this part of the rock? Till where, what depth it can sink? Now, can we apply this on a reverse engineering basis? Dekho, whenever a volcanic, imagine that there's a volcano which is present here. Let's imagine that there's a volcano present here. Now, there can be a rock that can be coming from this depth. This material has come out, so scientists ko ye rock mila. They'll study this also. And sometimes this rock which is there, the red color rock which is there, if scientists found this rock also, they'll study. Can't they understand by studying this rock that this rock is having, if in a lab, when you take and melt this at 5000 degrees Celsius, it is still not melting. And this is melting at just 200 degrees Celsius in the lab. We have that technology today. So by this technologies and studies, we can identify that this rock came from this depth. This rock came from this depth. Got it? And after a volcano that is poured outward, you go and study those rocks. Now what kind of material do you have? Sima, sial, knife. This is the work of geologists. We need not go into too deep to understand this concept. हम geography पढ़ रहे हैं, not geology. ये सब geology वाले का काम है, right? So in this manner, we study this earth. Likewise, now let's try to understand what is the earth made up of in terms of mechanicality. अब से हमें ये वाला टॉपिक्स इंपॉर्टेंट है एंड दिस इज नॉट. ठीक है, ये स्कूल में बचपन में पढ़ते थे. दिस इज नॉट सो इंपॉर्टेंट फॉर अस, बट यू शुड हैव एन आइडिया, एंड दिस कॉन्सेप्ट इज नॉट मच वैलिडेटेड. टुडे we have advanced studies, and in the advanced studies we always cater to this. Now from now on, whenever I teach you plate tectonics, you should be in a position to understand this. Whenever I'm talking about the plate tectonics, earthquakes and all, this is what we are going to study. See here, what I'll do is to make it little more simpler for you. Imagine this is your earth. Right? Look, what I've done is, I'll take a piece of this earth. Maybe, why am I doing this? Because in your books and all, this is how the diagram is shown. Many students do not understand why is this diagram there. When you open your NCERT, you'll find diagrams of this sort. So what I've done is, from the center of the earth, I've taken this slice of the earth. Now, see here, this depth is more, this depth is little lesser, This is having a different depth. Now this has a different depth. What we are going to study is layer by layer we are going to study. What do you have inside? What do not have inside? Likewise. So I'll separate this so that we can understand the concept in a better manner. I'll close the earth. ठीक है, right? So सबसे innermost layer, what layer you have? Inner core. I'll call this as, now above the inner core, what layer do you have? Outer core. This you have mesospheric mantle. Can I call this as mesospheric mantle? And this is mesospheric mantle. But within this mesospheric mantle, you have multiple divisions. That is upper mantle, intermediate mantle, and lower mantle. Right? So this is one layer. This is another layer. Then you have lower mantle. Above that, you have another layer by the name asthenosphere. Okay? Your asthenosphere is this part of the layer. And this is your crust. Right? So this is mechanical composition. Please look here once. This is lithosphere. This is what is asthenosphere? Can anyone? Asthenosphere means the weakest part of the layer. Okay? This part of the layer is literally the weakest part of the layer. Weakest in terms of its structure. Suppose, just imagine, do you remember I told you that there was a dam called Koina? When the weight is increased, the dam got earthquake. Why, you know? Look here. Imagine that I've constructed a dam here. Just imagine I've constructed a dam here and I've increased the water. If the weight is increasing, what happens is that this part of the region, especially the asthenosphere which is there, it is semi-molten. It is like plastic material. It is neither solid nor liquid. It is somewhere in between, like honey. You put something into honey, it will sink, right? Similarly, viscous material. So what happens is that the shape of this asthenosphere changes here. Your asthenosphere will become like this. And it will sink to the bottom. समझ गया? इस टाइप की characteristics है. It is simply like your pillow. When you put a head on your pillow, there will be a depression on the pillow, right? Similarly, this is what is happening in the asthenosphere. Now, see here, I have to tell you one more thing, that as you go deep into the interior of the earth, look here, I am going deeper. Temperature is increasing. Density of the material increasing. Right? These two things you need to remember. Temperature of the asthenosphere is more as compared to lithosphere. Upper mantle temperature is more as compared to asthenosphere. Density of this material is more as compared to asthenosphere. Now see, if suppose a P wave which is traveling through from here the P wave is traveling, the P wave characteristics will be like this. See, an earthquake got generated here. It is traveling through astrosphere, the speed increases, but their direction changes. Again, upper mantle, it is more denser, travels more speed, and then as soon as from here it touches the outer core, its direction deflects and the speed is reduced. Now once it enters into the inner core, its direction deflects and its speed increases. So we got to learn and study about these characteristics, and that is how we were able to. Now today, if you broadly look into, Earth is made up of multiple pieces. Now these pieces are none other than lithospheric plates kaha jata hai. If suppose this is your Earth, imagine this is one piece of Earth, this is another piece of the Earth, this is another piece of the Earth, likewise this is another piece of the Earth. Okay? Literally, when I take these pieces outward, this can be your India and this can be your China. Okay? In between, what do you see? You have some mountains. Now why these mountains form? Because China is also plate is moving in this direction and this plate is moving in this direction. But what is the depth of these plates? The depth of these plates are present only till lithosphere. So try to understand this. If I am putting this back again, this is China, this is India. That means there is some kind of changes that are happening. Now why these changes are happening, you need to understand. And why the mountains? Sometimes these two plates can move backward also, then you will have a big depression. Now that is nothing but your plate tectonics theory. Right? Yes. All this are primarily because of there are some changes which are happening in the interior of the Earth. Now what are these changes? These changes are none other than the mantle convectional cells. कुछ ऐसे changes mantle में हो रहा है. वो changes क्या है हमें जानना चाहिए. And also here I have to explain in little more detail about the interior of the Earth. Today I have given a brief introduction here, but see, your Earth has multiple layers. It has densities like this. Crust, upper mantle, lower mantle, outer core, inner core. Right? Inner core density is 12.8 to 13. Mercury का density उतना ज़्यादा होता है. Outer core 9.9. Lower mantle 4.5. Upper mantle 3.4. Crust 2.2. Do not write it, just I am giving you a reference point. Now, you have, as you go into the interior, till what depth these materials are found, that you need to know. Factual content है, याद करना है, कभी कभार examiner पूछ सकते हैं. Next, this is how your Earth looks. You have an inner core, outer core, mantle, asthenosphere, crust. सबसे weakest layer है asthenosphere. आप ज़्यादा weight you put in, your asthenosphere get disrupted, and someday what happens is that the more the weight you put, this asthenosphere get punctured. That means, you see, you keep on adding weight here, this asthenosphere will get punctured, and from here you can see earthquakes, you can see disruptions. For suppose you know that there are mountains which are present here. Will your asthenosphere be like this? No. In fact, you will have your asthenosphere bending like this. Very good. He says that sir, mantle के अंदर नहीं चला जाएगा. चले जाएगा. ठीक है, mantle के अंदर चले जाएगा, और ये weight ज़्यादा होने से ये जो plate है ना, it can get disrupted. These changes we'll learn in tomorrow's class. ठीक है? Got it? अभी यहाँ तक समझ में आया? Right? See, even if you do not have any previous knowledge, you can understand all the classes from today onwards. It is just geomorphology, a new topic has been started. So primarily, you need to know about these layers. And see, tomorrow I'll discuss in further more detail about, I'll compare these two. What I'll do is, how these classifications are done. You have crust, core, mantle, and they are further divided into mechanical and chemical composition. Tomorrow we'll learn in little more detail. यहाँ तक clear है? Okay. We'll stop here and we'll continue in tomorrow's class. Outer core में speed ज़्यादा होता है P waves का. Deflection भी उतना ही ज़्यादा होता है, speed भी उतना ही ज़्यादा होता है outer core में. The highest speed is in the outer core. And you will be surprised to know that the width of the outer core, that means the length of the outer core, 3500, this is the 6370 is the radius of the earth. Now 3150 to 6370, near about 3000 kilometers is the inner core. And 2900 se lekar, this is Lehman's and Gutenberg's discontinuity, 2180 kilometers is the width of the outer core. Inner core is 1200 kilometers, near about. There it is written from discontinuities, I'll tell you. Now here, crust is just 400, asthenosphere it is 400 or so, and 2250 is the mantle. So, which has lower size and more weight? Inner core size is smaller, but the weight is more than 35% of the weight is with inner core. Mantle 2180, sorry, outer core 2180. This is the liquid part of the earth. Maximum deflection, nahi, maximum velocity. Maximum velocity is in the inner core. So here, by studying these waves, we got to know in detail. Tomorrow, we'll learn about this in little more detail. Okay? When you know about these layers, all these layers, sometimes you see, I've put a rock. Just imagine there is a volcano here, and I have decided to put a rock into the volcano. Some rocks can reach deeper if that volcano has a vent till here, right? I have a volcano here. Some volcanoes can be present only till this depth, right? That means my volcano will have rocks here. Yes? Floor. देखो volcano का floor is not here. Volcano का floor यहाँ पे हो सकता है. Volcano का floor यहाँ पे हो सकता है. You cannot estimate just by looking onto the volcano, this is the floor. No. The volcano has a vent, and the vent can be so deep. We can't estimate the depth. It is always learnt, the volcanic material is studied and learnt in such a way that if the density of the material matches with any of these layers, we say that this is the depth of the volcano. Okay? Maybe some rock came from here. That means the density of the material would have been more. Based on that density, we identify that what kind of material you have. The highest density material which we have ever found is here. Right? Mercury, ferrous, iron and all, they have high densities. This is also made up of knife, this is also made up of knife, but this is made up of pure knife, this is made up of impure knife. And you see, let's imagine that you have a person standing at place A, you have a person standing at place B, C, D. Who will be experiencing more weight? Who will be experiencing more weight? E will be experiencing all the layers of the weight. Now, inner core is experiencing more weight. And who is having more temperature? Inner core. So, at such high temperatures and very pure material and high density, that is solid. This is little impure and comparatively less temperature, so it is liquid. That is the primary reason which you have. Rare earth metals, that has nothing to do with this. Rare earth metals means, rare earth metals means it is not that they are not found anywhere, they are found everywhere. But unka mining, if you are mining 100 kgs, you might get 0.2 grams. That is why it is called rare earth. अगर वो materials को पाने के लिए आपको large surface area dig करना पड़ेगा. That's why it is called rare earth. But it is not found It is found everywhere. Commonly it is found. So polymetallic nodules आपने सुना होगा at the surface of the earth. Now those rocks which are there, उसके अंदर highest concentration पाया जाता है. So we'll stop here. Any doubts as usual? क्या? Magnetic field and all I'll explain further. The reason is you have a solid inner core and you have a liquid outer core. आप solid के which is made up of knife, which is also made up of nickel, then there is a liquid moving. Is it not a solenoid? That's why you have it. So online, I know you have many doubts. I won't take doubts today because you are bound to have doubts. All these doubts will be cleared in tomorrow's class. Concept समझ में आया ना? That's it. So today please go and read the chapter number 2 of class 11 NCERT, that is fundamentals of physical geography. Right? Any doubts? You can drop a message here, right? Online. And photo चाहिए तो जल्दी ले लेना. And ठीक है, thank you online.